Hello, and welcome to Retro Tech Repair. Today we're going to be repairing what I considered at the time of its launch was the very best console that money could buy. Back in the early 80s, if you wanted a video games console, you had quite a few to choose from. The popular choices for the rich kids were the second generation consoles, like the Atari 2600, the Philips G7000, and the Mattel Intellivision. Then, in July of 1983, almost a year after its US launch, the CBS Colecovision came to the EU. So I use the phrase CBS Colecovision because that's how it was known to me. I have heard in the US market the console simply went by the name Colecovision. Now over 35 years later I finally own my own Colecovision that I bought on eBay. This one was advertised as in working condition, so today we're going to see if that's true, repair it if it's not, restore it, and enjoy firsthand the Colecovision experience. So let's get started. Taking a look around our Colecovision, it seems to be in nice condition. There's no obvious cracks in the plastic, the front panel is nice and shiny, and no significant marks or scratches. The controllers and other features on the case seem to be in nice condition too. Overall, I like the look of the machine. Its black plastic and brushed aluminium effect make it look altogether more modern than the Atari 2600 or the Intellivision with their wood grain effect. The controllers have a membrane-style keypad, a joystick with two fire buttons, and an Atari-style 9-way connector, and they fit neatly into the console for storage when not in use. To the rear we have what looks like a custom connector for input from the power adapter, and a hardwired antenna or aerial connection. This radio frequency RF connection was the only way of connecting consoles to TVs of that time, and most TVs did not have a composite or other input. So to connect your console to a TV, you would normally disconnect the TV aerial from the back of the TV, and then connect the console into the same aerial socket. Then you would retune the TV to pick up the RF video and sound signal, which would be generated by an RF modulator within the console, almost like a miniature TV transmitter. Back to the console, and on the top we have an aluminium cover over the cartridge slot and a power switch. On the front, an expansion port, which could be used to attach various accessories. Among the available accessories was an Atari 2600 adapter, which allowed the Colecovision to play Atari 2600 games. I don't remember any other manufacturer that produced a console that had an adapter to play games from a competitor's console. Taking a look at the mains plug now, and it was common at the time for devices to be supplied without a plug, requiring the end user to buy and fit their own. I am pleased to see the plug does have a correctly sized 3A fuse, but I will probably go ahead and replace the plug anyway, as these older Bakelite plugs are now becoming quite desirable, and I can probably sell it on eBay for around £10. Okay, so we have our new plug on, but before we connect it to the console itself, I'm going to check the voltages on this power supply. So pin 4 is the common, and then we have 12.3 volts, minus 4.9 volts, which may be a little low, but should be okay, and then plus 5.2 or 5.18. So I think we're good. I think this is going to do what we need it to do and power our Colecovision. What we need to do next is get it hooked up to a television. Okay, so we have our TV connected up now. We have the Colecovision powered off its power brick, and we have the RF cable that I showed you a little earlier connected onto the back of the TV, and now we're going to search through the channels on the TV, or have the TV auto search, and then hopefully we can find where our Coleco is. There we go! I think immediately obvious though now when we look at this is that this is black and white and it has some ghosting on it. And now ghosting is not uncommon, I think, because of the RF arrangement that we talked about before, but it should be colour, and this is a bit disappointing because I did buy this as being a working Colecovision. However, let's see if we can fine tune it in a bit on the TV. Unfortunately, despite my best efforts fine-tuning the television channel frequency, I still was unable to get a colour display. Let's try it with a game. Well, it is Donkey Kong and it's very much in black and white. Hopefully, we should be able to repair this and get it good to play again. So the Colecovision is notoriously difficult to open. I start by removing the game cartridge and joysticks and power connector, and then I remove the screws from the bottom of the case. There's a small plastic blanking plate at the rear which I remove, and then the difficult task of separating the upper and lower enclosure begins. What makes this so difficult is that the lower enclosure is connected to the front panel, and although this front panel could be removed, the screws for it are hidden behind the brushed aluminium trim. Reading the instructions from the service manual I find online, the two halves can be pulled apart with a little effort, but I have to resort to using a pry tool. I have to be careful here, as the plastic around the expansion port is fairly thin, and by now over 35 years old. We can now see where the power connector connects to the main board, which is contained within this metal RF shielding. The UHF TV modulator is what generates the RF signal for the TV. It sits on a separate card with a multi-pin connector to the motherboard. The power switch also sits on the main board, and this is a notorious failure point, so we're going to start by cleaning the switch with some electrical contact cleaner. I'm working it back and forth a few times, and I've put a towel under the console just to avoid getting the contact cleaner on my desk. Connecting the console back up to the TV and powering on shows that in fact this made no difference, and the display is still black and white. So we're going to have to delve a little deeper into this and see if we can troubleshoot the problem. I start by removing the RF cable, which just unplugs from the RF modulator via a phono RCA style plug. I remove the screws holding the metal RF screen in place and lift it away to reveal the main board. Looking at the printed circuit assembly, we can see the memory and the CPU, which is an NEC D780C, which is a Z80 compatible processor. There's a TI video processor which is hidden beneath the heatsink, some further video driver circuitry, the TI sound chip, and some logic chips. From the top of the board we can see some electrolytic capacitors, but they don't seem to be bulging, and I don't see any visual signs of damage on the board or components. Let's take a look underneath. Okay, so there were a couple of things. There was a couple of screws holding this printed circuit board in. I took that out, and then there was another screen underneath the PCA which I've just kind of slid out. I don't see any obvious damage, I don't see any kind of burnt parts or anything like that. It looks like there's been a couple of places where we have some rework, whether that was original to the factory or whether it's been some subsequent repair. Whether that's still a good repair or not, I don't really know. Nothing that jumped out as being in a bad cosmetic condition, which might indicate that it had failed. I think the next thing to do for us now is to start taking some voltage measurements. I have power connected up, my meter set to DC volts, and the negative lead of my meter connected to the ground on the main board with the crocodile clip. Using the probe, I am able to confirm that we have plus 5 volts, minus 5 volts, and 12 volts at appropriate places on the board. So having confirmed that the supply voltages are not the problem, I now turn my attention to the video circuitry. I did find a service manual for the Colecovision online, however every copy that I could find was for the US NTSC console. The video circuitry for the PAL version is much different. It uses a different version of the video processor, it derives its clock signal in a different way, and it has a different video driver circuit. Fortunately, the video processor used in the PAL Colecovision was also used in a number of home computers of the time, including the MSX computers and the British-made Memotech MTX and Taitung Einstein computers. I was able to find a service manual for the PAL Memotech MTX 512, which describes the troubleshooting procedure for a loss of colour, so I decided to follow the troubleshooting procedure described in the Memotech service manual. So I have on my laptop the service manual for a Memotech MTX 500, and it tells me to look on pin 17 of LM1889 for an oscillation of about 3 volts peak to peak. According to the datasheet for the LM1889, pin 17 is the chroma oscillator output. So if we don't have a chroma oscillator, then this could be our problem, and that could explain why we don't have color. So the only way I'm going to be able to tell if I have an oscillation signal on that is to use an oscilloscope. So I needed to Google how to use this oscilloscope, so forgive me as I struggle through that. But what I'm looking for is, according to the Memotech manual, I should have on this pin of the LM1889, the video converter pin, I should have a signal, which I do, and it says it should be 4.433 megahertz. This scope rather nicely has a ability to measure the frequency, and it's saying 4.405, 4.24, so there's a bit of variability there, but it seems about right. What it said in the Memotech manual, Memotech by the way uses the same video chip as the ColecoVision here, is if you don't see that signal, replace that this LM1889. But I do see the signal, so I'm guessing then that this particular chip isn't the problem. We should look elsewhere. So having tested the LM1889 and concluded that it is not at fault, I decided to look for the video signals coming from the video processor. I'd expected to see 1 volt peak to peak, but the amplitude of these signals seemed low to me, so I decided to test each of the transistors on the motherboard in case they were being used as amplifiers for the signal and had failed. I have described transistor testing in my Munchman and Astro Wars videos, so I won't repeat that here, but I did find one transistor, Q2, that did not behave as expected when measured with the meter. I decided to remove it from the board and tested it in a component tester. This gave me a chance to use my new desoldering tool. It didn't work very well, though I later discovered that it was blocked with solder from a previous repair, and when I cleared the blockage, it worked just fine, and I was able to remove the suspect transistor and test it. So a couple of interesting things happened. First off, I don't know if you can see that, but my transistor checker broke, and then we have in here the transistor that we removed, and although it's broken, when it tests it, it actually shows it as being a good PNP transistor. So this transistor actually is not faulty, and when we tested it on the bench, I did not see the same behavior that I saw when it was connected into the device. So there must have been some resistors or some other parts in parallel with it in the device which caused it to appear differently. So I decided to turn my attention back to the video processor and associated circuitry and look again at this LM1889. According to the Memotek MTX manual, which I'd been using to help me troubleshoot the Colecovision, we should have a frequency of 4.4336 1875 MHz at pin 17. Measuring this with my oscilloscope, the frequency on my Colecovision does not exactly match that we're looking for, looking more like 4.44. I'm not sure if this is just the way the scope measures the frequency, but I decided it was worth replacing the crystal oscillator to see if it fixed the problem. I found these new crystal oscillators on eBay with a frequency of 4.4336 1875 MHz. Perfect. I was able to easily remove the old one with our new unblocked desoldering tool. I soldered the new oscillator in place, powered up the Colecovision, and again measured the frequency with the oscilloscope. It didn't look any different, but I decided to connect it to the TV and try it anyway. Okay, so we didn't see any improvement on the oscilloscope, but that could just be measurement error on the oscilloscope. So let's see if replacing this crystal fixes our problem of a black and white Colecovision. No, of course it didn't work. So next I tried to replace the LM1889 itself. This is the first time I've had to remove an IC, and I found it a bit fiddly, but eventually I was able to unsolder the chip and remove it from the board. Since my soldering skills are not great, and to aid in replacement in future, if I needed, I decided to solder a socket into the board and then install the new chip in that. I used a little heat-resistant tape to hold the socket in place, and then soldered it in, being careful to ensure that enough solder is applied to flow through each of the holes, as this is a double-sided board. I then installed the replacement chip in the socket, and I again measured the frequency on the oscilloscope, and it looks exactly the same as before. Nonetheless, I decided to hook it up to a television and see if colour has been restored. Okay, so it's the moment of truth. No, it's still black and white. You know, I was a bit nervous when I saw that signal on the scope, and it was just the same. That is disappointing. All that effort, yeah, but still black and white. Well, I guess the good news is it still works. So our replacement of the LM1889 was successful, but we still have this problem that our display is black and white. So I finally ran out of ideas on our Colecovision. I couldn't figure out what I needed to do to get a colour display, so I thought, well, you know what, I'm just going to try it on another TV. The TV that I've been using it on I repaired earlier a couple of weeks ago, and actually it's never had a colour sort into it, although it displays colour graphics. I thought, well, the colour must be fine. So anyway, I thought, well, I'll try it on another TV. So I moved into the bedroom. This is our bedroom TV, and when I select the Colecovision channel, I get a perfect colour display. So I'm not sure what happened. I'm not sure whether it would always have been that way, and it just wasn't working on the other television. Whether there's something wrong with the other television, whether there's an incompatibility or not, I don't know. But I might just have been chasing my tail with this one. So I decided to double check the TV that I've been using can in fact display colour by connecting it up to my laptop. And at least via HDMI it works just fine. So it seems we have some slight incompatibility between the Coleco and the TV that I have. So not really knowing where to go next, I decided to take a look at this Aztec UHF modulator. The metal cover is clipped into place and is easily removed by pressing upwards with a screwdriver. Inside there are transistors, capacitors and numerous adjustable presets, but I know that if I attempt to tweak any of these, I won't ever be able to get them back where they were. A quick visual inspection doesn't reveal anything obvious, no burnt parts or swollen caps, so I decide just to spray everything down with an electrical contact cleaner, give it a good shake and wait for it to dry before reassembling. I also decide to clean the connector to the modulator board, so I spray a little electrical contact cleaner on that and then work it backwards and forwards. Whilst I'm doing that, I notice some kind of deposit, I think actually probably a dead insect or something, on the Coleco mainboard. So I clean that also with a little IPA and connect everything back together for one last try. Okay, so let's give it another go. Wow, finally, here we have our colour Colecovision. Isn't that funny, after all that kind of messing around with this timing circuit and video circuitry here, finally it was the kind of cleaning of the modulator, the cleaning of these connections and the cleaning of the printed circuit assembly where we had a few parts that brought colour back on this display. And with the benefit of hindsight, I think a thorough clean of the board and modulator would be my starting point. I would definitely try alternative TVs, and only then would I turn my attention to the video circuit. In my mind, I still believe that although this wasn't the cause of the problem in my console, a faulty LM1889 or a failing crystal oscillator could still be the cause of a black and white only display. But in our case, I don't believe these parts were at fault. So we're going to leave it there for our Colecovision for now. But this isn't the last time that you'll be seeing it. I'm going to be modding it to give it a composite video output, perhaps making it more compatible with modern TV connections and hopefully improving the picture quality too. That mod should also allow me to connect the Coleco up to my video capture card and take a look in more detail at some of the games for the system. This is all to come in future videos, as well as repairs of some of the Coleco's competition, including the Atari 2600, the Intellivision, and the Magnavox Odyssey 2 Philips G7000. But until then, I hope that you've enjoyed the video today, and thank you so much for watching Retro Tech Repair. Hi, what's inside here? That could be a problem. Just the joystick works as it should. Great. I don't know if that's skill level or number of live around. I have it in a couple of places and then it stops. Grandstand scramble. Wonderful. Looking forward to fixing that.